Good morning. My name is Nicholas Spalding. I'm the SI instructor for Math 1121. Today we'll be going over Chapter 5, Section 5.1, Antiderivatives. We're going to start with the lecture notes that's posted on the Moodle website. Example 1A through C. Example 1 reads, find the antiderivatives of the given functions. We'll start off with A. F of x equals 5x to the fourth. We want to find f of x. Okay, I'm going to write the forms up here, the general equations, which is k. This is the derivative form, and we want to take it to the antiderivative form. F of x to f antiderivative. So we're gonna start. I'm gonna start with this equation, and then work it the other way. I'm gonna work it two ways, really. Okay. Let's move this over. We're gonna use this equation and plug it in to find the antiderivative. We're gonna list our u and our n plus 1 equals. Okay, then we got the function in the derivative form. We have n, which is 4. So n equals 4. 5 is the constant k. So we're going to bring that out to the side. So n equals 4, n plus 1 equals 5, u equals x. So just plug that into this equation. U equals x, n plus 1 equals 5, over n plus 1 to the 5. So that equals 1/5 x to the 5 is the antiderivative. And to check it, take the derivative of that to check it. X to the 4. Oh, I forgot to bring. Remember that constant I took out? Don't forget to put that back in. Yeah. Don't forget to put that back in. So that 5. So it's the antiderivative is these 5s cancel out. X to the 5th. And to check it, take the derivative of that equals 5x to the 4th. The TI 89s, they give you the antiderivative and derivatives, but no, the 89.
Oh, the 89.
Yeah. Do you know how to put under y equals? Do you know how to put do you know how to do the derivative in there? Like after you
I've done it before, but I don't remember it.
It's something like x comma x. I have to look that up. Let's see if I can find it. Derivatives NTI 83. You got 83, right? It's helpful checking work, but first you must always find it about calculation. So let's try this.
How'd you get to that?
That's y equals, mine was on polar though.
Oh.
So we're going to try to take the derivative. We're going to check it. So we're going to take the derivative of what we got, x to the fifth. And see, we should get 5x to the fourth. So try press math. Up. Number 8 is in derivative. To select and press enter. -8. So we can put variable 1, comma, x, comma, x. Enter.
Wait, I can't really see.
You can't see it? We zoom in right here. Okay, I'm gonna do it one more time too. Math, number 8 option. Variable, y variables, function, y1. That's the y1 we entered right here.
Okay,
Comma, x, comma, x. That last x would be if you were looking for to plug something in x. If we were looking to plug something in the x, you would put the, 6, if you wanted to find.
Okay.
And then close parentheses.
We've done this before, right?
Yeah.
Okay.
Let me delete one of mine. It might tell you after you graph it what the function is. I just want this one. Yeah, it won't tell me the actual function.
But then I could just also go in and type in the function.
Yeah. What you instead of typing out a derivative?
Type that and then type the function.
Oh, to see if it graphs the same. Yeah, that's a good way to do it. So let's try that.
Yeah, they match.
They do.
Mhm.
X to the fourth. Graph those two, and if they match, then you got answers right. Okay. I can erase this one?
Mm-hmm.
I'm gonna grab a paper towel real quick.
Okay.
Take like a wet paper towel. I can write over that, but number B is f of x equals 4/3 x to the 1/3. I should have left all that stuff. K x to the n to k n to the x n minus 1. This is f of x. This is the derivative. Take it to the antiderivative. We can use... Oh, I forgot to work that one the other way. I'll just do this one both ways.
Okay.
U n plus 1 over n plus 1. N plus 1. Appreciate it. Thank you. Constant term. We can pull this out for now. List u equals x, n equals 1/3, n plus 1 equals 1/3 plus 1, which is 3/3, and n plus 1 equals 4/3. Plug into our equation. U equals x, n plus 1 equals 4/3, over 4/3, which can become x 3/4. Plug our constant term back in, which is 4/3, 3/4, which cancels out, x to the 4/3 is our answer. F of x equals x to the 4/3. And so if we want to check it, take the derivative of that, which is 4/3. The derivative is n to the u n minus 1. So n equals 4/3, u equals x, n minus 1 equals 4/3 minus 1, or 3/3. So 4/3 x to the 1/3. And that's what we got.
Wait, shouldn't... Where did you get the 3/4?
This one?
Up there. Well, yeah, that one too, but...
This the 4/3 on the bottom is 3/4 on the top. It's
okay. I get it.
See what I'm saying, Connor?
Mm-hmm.
You erase this one?
Mm-hmm.
Okay. C. F of x equals -6 over x to the 5th. We want to rewrite this to get the exponent in the top, just to make everything easier. So we can rewrite this to -6x to the -5th. And we can apply this formula to it. -6 is our constant term. So we can take this out. We left with x to the -5th, u equals x, n plus 1 equals -5 plus 1, which is -4. Is it? So u equals x to the -4 over -4 with our constant term. Simplify. 2 goes into this twice. 2 goes into this 3 times. 3x to the -4 over 2 equals f of x. To check our work, we will take the derivative of this, which is, we have 3 halves x to the -4. So the derivative would be 3 halves times -4x to the -5 and u to the n-1. Cancels, left with -6x to the -5 or -6x over x to the 5th.
Okay.
Got it?
Yeah.
I forgot. I'm gonna do this one with the the other method. Okay.
Is that over a -2?
Right here?
Yeah.
No. No.
Okay.
Sorry about that. Leave this up. Okay. The same problem is f of x equals -6x to the -5th.
Do I have to know how to do it both ways?
No, that way simpler. I think the only reason this one is good is because for the chain, when you have to do the chain rule,
Oh, okay.
it's similar to that. But that's this.
And we're gonna have to do that, right?
Chain rule, yeah. But that's when you have the, parentheses and exponent, x plus 1, something like that.
Yeah.
So, start with, we wanted to get it in this form. We'll list everything we know. So we're going to start with n minus 1. Our n minus 1 equals negative 5. K. We want to find K. He has this as, because this is given to us as the derivative already. So that's what he has. I'm going to start with the example. I'm going to do it first with the example he worked in class. Okay. And then try to see how it works. Okay. Find the antiderivative. So we want to simplify first. X to the 1/2 minus x to the negative 3. And then this is 2 over 2. So x 3/2 minus x to the negative 3. And then he lists n minus 1 equals 3/2. And n equals 5/2. So to find n from this, you would have to add 1 to it. Add 1 to get in, or
Okay.
to go the other way.
Okay.
Because the derivative, it goes this way, n minus 1. So the antiderivative, we want to add 1 to it to find n. I used to put n plus 1. I used to go ahead and put n, but I don't want to confuse you though. I want to just stick to the way he was doing it.
Okay.
So, but when you're doing this method, n minus 1 is already given to you.
Okay.
And then add 1 to it, and you have n, and you're looking for k. So, rewrite the equation. You want to rewrite it like this. So, n equals 5/2. That's your u equals x. That's u, I think. X to the n minus 1 is 3/2. And that equals your function, your original function, which is x to the 3/2. And then you want to find k. So you know this x to the 3/2 cancel, the same on both sides. And you want to make this side, so you want to, you got your 1 right there. So basically 5/2 k equals 1. You see that? From over here.
Yeah.
And then solve for k equals 2/5. And then, so rewrite it. You will rewrite it back as 2/5 x to the 3/2. 2/5 x to the 3/2. And if you want to check it, that's 6. That's not right, is it? So we messed up somewhere. And I put n minus 1 when I rewrote it.
Mm-hmm. Instead of just putting it in.
So when you write it, you want it to be in this form. Oh, so it's n right there. N minus 1.
The answer I got in class was 2/5 x to the power of 5/2
Minus that, but that's the other part.
plus 1/2 x to the power
Yeah,
of
that
negative.
1/2 x is this part. Well, we haven't did that one yet.
Okay.
So n, I might have these backwards. That's not right though. Put n back here. So the 2/5 x to the 5/2 after you find your k. So that's I'm sorry.
Okay, never mind. Go ahead.
You wanted to look like this, ku to the n.
I thought you wanted it to look
like this
like
one,
the
right?
other one. Yeah.
That's the antiderivative. Kn n minus 1 is 3/2 on this one. I don't know, but he plugs n back in. Let me see on this. He plugs n back in, but let's do one on his solutions. Can you see that? Let's do one of his solutions and
Okay.
we'll know exactly what he did. Okay, number 1 says f function equals x squared plus 2 plus 1 over x squared. Okay, I'm going to start with the x squared. It's going to be red. X squared, let's do it this way. So we will list what we have: u equals x, n minus 1 equals 2, and that means n would be 1. No, n would be 3. So, and then let's do like this: k to the n. I wonder if that's what we didn't do last time. Put that n right here. To the u to the equals x squared. He didn't even do it that method though. So that's right. Okay. You see what I did wrong the last time? I had to go back, but I didn't bring that in. I did KU to the n minus 1, and then I left the n out when I was rewriting it.
You left the n out.
Uh-huh.
Okay.
So I go back and do that one again, though. But, do you see this? Do you see how I did this one?
Yeah.
Oh, appreciate that. Thank you. And then I'm gonna do it the other method right now too. The u to the n plus 1. It's starting to get jumbled up a little bit. And this will be down here. I had n minus 1 b prime. Okay, so you understand this one? I'm gonna do that one with the u n plus 1. So we started with x squared, and we want the antiderivative of that. And we're gonna use this one this time. So let's just write everything we know. U equals x, n equals 2, n plus 1 equals 3. I think that's all we need. Plug it in, x to the third over 3, which is 1/3 x to the 3. I didn't rewrite this. Over here, our k is 1/3. Our n is 3. Our u is x. Our n minus 1 is 2. That cancels x squared. So what's our... We found k. What's the derivative of that? That's okay. If you put an n in there, then that cancels out. think I just confused myself, but that, that's the form we needed in. You see how you understood all this, right? And then when you write your final answer, it has to look like that. And then you take the derivative of that, and you get x squared. But that's our answer. 1/3 x to the third. And we got the same thing over here. 1/3 x to the third. That's just that first part of the problem. So that 1/3 x to the third. I'm gonna erase all this. Okay. Second part of this problem. 2 is really, you can do the work. Oh, you know, 2. Because U is, 2, I mean, you know it's 2x, right? The antiderivative. Because when you got 2x, what's the derivative of that? What's the derivative of that is 2.
Okay.
So that's more, let me see what he does it. He does 2x. I don't even think he didn't even show any work on his solutions.
Okay.
So you know 2 is 2x plus 2x. And then this last one will be, I'm gonna rewrite that as x to the negative 2. And then take the antiderivative of it this way first. So U equals x n plus 1 equals negative 2 plus 1 equals negative 1. So U to the n plus 1 over n plus 1 equals negative 1, x to the negative 1, or negative x to the negative 1. And to check it, we will...
I'm really confused.
Okay. I just listed my... I'm taking the antiderivative. I rewrote this last time. Then I rewrote that. Then I started listing my U n plus 1, which I took negative 2 plus 1 is negative 1. And then I used this equation, U n plus 1 over n plus 1.
Okay.
And then simplified. And then I got this. And then I'm going to check it and take the derivative of that, which is negative. There's a negative out here, negative 1 out here. Negative 1, negative 1. I'm using this. And, well, that's the constant term. Constant term n. U n minus 1 is negative 2. That doesn't apply. And that's 1x to the negative 2, or 1 over x squared. And I'm going to do that one the other method also. So that that's going to come over here for the final answer also. So your final answer for this is right here, which is negative x to the negative 1 equals f of x of this.
Okay.
So this goes in here, plus 2x minus x to the negative 1. Or you could write it 1 over x. And to do this the other way, you would take this as n minus 1 equals negative 2. You would, your u would still be x. And you would look for k. And then plug that, write it like this, in this form, k. N would be this plus 1, which is negative 1. U, n minus 1. And all of that equals to the negative 2. This cancels. So negative 1k equals 1. K equals negative 1. And then write it back like that. Negative 1x to the n, which was n
What's that in?
negative 1. And that's negative 1 over x. Same thing.
Is he gonna put those equations on the quiz?
The what?
Those formulas on the quiz?
Right here? I think so.
Yeah.
Let me see. Does he put? Does
like
he got
that third one?
Yeah, he got which one? This one?
I mean the second. Yeah.
It's not on the top of this one. Cause he taught this one as a second method, right? I think he taught this method first, this blue one, and then taught that one.
Okay.
But he taught. I saw him put it on the board Monday. I think that wasn't Monday the first time he used that one.
I think so.
It's much easier, especially if you don't have the chain rule in there. What is that? You got this one?
Yeah, I got it.
I'm gonna go back and do the. You want me to go back and do that other one? What were we looking at? We was looking at.
We can keep on with the
With the
quizzes.
quiz?
Yeah.
Okay. So number 2. Okay. Number two reads, nine cubed root x minus 3 pi squared. I'll start off with this one. All this is a constant term, just like the 2.
Mm-hmm.
So you just put an x at the end. To take for the antiderivative, put an x on it, so it'll be 3 pi squared x will be the antiderivative. If you take the derivative of this, you just let it go with the x. 3 pi squared. Thank you.
Keep this going.
So we got that part of the problem. It'd be negative 3 pi squared x. For the first term is 9 cube root x, and you could rewrite that as x to the negative 1/3. I mean x to the 1/3. And then we can use this rule again. UN plus 1 over n plus 1. This one. We'll take the constant term out. You have your u equals x. N equals 1/3. N plus 1 equals 1/3 plus 1 equals 4/3. Equals 4/3. Plus constant terms was taken out. U equals x. X. N plus 1 equals 4/3. All over 4/3, which is 3/4 at the top. So you can rewrite this as 3/4 9x to the 4/3, which is 27 over 4x to the 4/3. Is that what he has? Yep. 27 over 4x to the 4/3. Now to do it the other way, we would write n minus 1 as 1/3. Our u would be x. We're looking for k. And start plugging it into this equation. K, which we're looking for. N equals 1/3 plus 1 equals 4/3. So K 4/3 x is our u. N minus 1 is 1/3. And it equals 9x to the 1/3. X to the 1/3 cancels out. So 4/3 k equals 9. K equals 9 times 3 over 4, which is 27 over 4. Rewrite it like this, where k is 27 over 4, u is x, and n is 1/3. N equals 1/3 plus 1 equals 4/3. And it's 4/3. Is that what we got? Yeah. 27x to the 4/3. Okay. You got this one?
Yeah.
Oh, that's not, is that the whole problem? Yeah, that's the whole thing.
You just
So
gotta
that
put
goes
those
on.
two together.
Yeah. So that 27 over 4x to the 4/3 will be right here. And that's the whole answer. Okay, next problem. Oh, too much. Be tired by the time I finish. Okay, number 3. Number 3, f of x equals square root of 4x plus 3. Chain rule. We can rewrite this as 4x plus 3 to the 1/2. And we're going to start out by listing all information.
Just write it down every time if you need.
Okay, appreciate that.
No problem.
Thank you. U equals 4x plus 3. N equals 1/2. N minus 1 equals 1/2.
And the K is just 1.
Oh, I think you need to find the K.
Okay.
Yeah. N minus 1 equals 1/2. Just like the other form where I took this N minus 1 is what they give you.
Mm-hmm.
N minus 1 equals 1/2. I'm going to go ahead and find N, which is 1/2 plus 1 equals 3/2. And start plugging into this one, where we're looking for K. N equals 3/2. U equals 4x plus 3 to the N minus 1 is 1/2. And all that equals 4x plus 3 to the 1/2. And so,
Why is that? Oh. Never mind.
you got it?
Yeah.
Okay. This is where this formula starts applying. N to the U, N minus 1 to the U prime. And I forgot to do that in here. So this is K N U N minus 1. And then since you just this the chain, you have to use the chain rule for this one. So The derivative of 4x plus 3 is 4. And all that equals 4x plus 3 to the 1/2. And to find the k, you know these cancel. 4x plus 3 are the same thing. 4x plus 3.
Where did the 4 come from?
The 4 is the u prime. The derivative.
The inside?
Uh-huh.
Okay.
The derivative of the inside. And you know these cancel out. You want to make this side look like this side. So to cancel out, you want to make this side look like this side. So you have to cancel out the 3/2 and the 4. To do that, you could multiply both sides by 2/3. That'll cancel the 3/2. And 1/4 will cancel out the 4. Multiply those together, and that's 2 to the 12, or 1/6, equals k. And then go back and write it in this form. K equals 1/6, 4x plus 3, n equals 3/2. And that's our answer. If we want to check our answer, can you erase this at the bottom?
Mm-hmm.
Okay. We're going to check our answer by taking the derivative of our answer and using this equation. So for this, to check it, our n would be, our k is 1/6, n would be 3/2, n minus 1 equals 3/2 minus 1 equals 1/2. U equals 4x plus 3. U prime equals 4. Let's plug it in. N equals 3/2. U equals 4x plus 3. N minus 1 is 1/2. U prime is 4. Is that... that should give us this... Let's see. Don't look like 6. Hmm. 3/2. That's what we got. 3/2. 3/2 n times u to the n minus 1 times u prime. And we get this. 6. I didn't put the 6 in there. I'm sorry. Take the derivative of this, 1/6. I'm gonna do it again so you see it. Okay, take the derivative of this. K is 1/6. N is 3/2. U is 4x plus 3. N minus 1 is 1/2. U prime is 4. So this is 2. That's 6. That 6 cancels both of those out. So you're left with 4 plus. Cool.
Yeah.
Let me go ahead and spread.
Just spray on the board.
What's that?
Spray, like on the paper towel or on the board?
On the board.
Oh, gotcha. Okay.
Oh, don't spread. Okay. Number 3. Number 4, I mean, sorry. It's 4 total on here. Yeah, 4 total.
Mm-hmm.
We're on number 4?
Yeah, or number 4.
Okay. Number 4. F of x equals x cubed 2x to the 4th plus 1 to the 4th. Okay, let's start listing what we know, which is we know u, 2x4 plus 1. U prime equals 8x to the 3rd plus x. Using this, they give you n minus 1 equals 4. So that means n would equal 5. And let's start plugging in. We're looking for k. Plug it in. K to the n, which is 5. U, 2x to the 4th plus 1. N minus 1. U prime. U prime is 8x cubed plus x. He doesn't have, he has for U prime 8x cubed instead of 8x cubed plus x. But when he, in the antiderivative, the derivative, that's why. Okay. I took the derivative of this one, then the antiderivative of that one. But I was take the derivative of both. So the derivative of a constant is 0. Yep. And all that equals the function. And look for find K. So these will cancel. X cubed will cancel. So you're left with 40K equals 1. K equals 1 over 40. And so we go back and rewrite it like this after you find K. So K equals 1 over 40. U, which is 2x to the 4th plus 1. N to the 5th power. That's it. So basically, you know how the quotient rule, you have to use this one, kinda, the x cubed. You don't really use that one for. You don't ignore it, but you almost do. You want to check this one? Do the derivative of this? Okay. So we'll be using this one. K is 140. N is 5. Bring N down, 5. 2x. 2x to the 4th plus 1 is U. N minus 1 is 4. U prime is 8x to the 3rd. See what we get. This cancels to 8 on the bottom. That 8 cancels. You left with x cubed, 2x to the 4th plus 1 to the 4th. Yep. Cool. You wanna go back to that example? Yeah. And did you understand this one is 3R1? 3R squared plus 1?
Where's that at?
Example A on section 5.1. No, example 2A, section 5.1. It's right here. Right here. You see it?
Well, I didn't get that one, so
Okay.
we should go over that.
Okay. That's it. Okay. Thank you. Okay. I'm gonna write my equations back. Okay. First, we're gonna list our U. Okay. U equals R squared plus 1. U prime equals 2R. Rn, they give you n minus 1 equals 2. That means n equals 3. And then plug in to this equation. We're looking for K. K, N, 3. I'll keep putting the X up here. R squared plus 1. N minus 1 is 2. Times U prime, which is 2R. And then all that equals the function, the original function. And find K. 3's canceled out. R squared plus 1 squared cancel out. 2R cancels out. K equals 1. So write that back like this one. K equals 1. We got U, R squared plus 1. N is 3. That's it. So this is our answer. And we're going to check it by taking the derivative of our answer. Take the derivative of our answer. We will, using this, we will get 3 R squared plus 1 squared times 2R. And that's what we got up here. So we know the answer's right.
it was the other C. Or no, it was
This C?
yeah.
Okay. That's when I stopped and went to the, okay. F of x equals negative 6x to the fifth is the problem. So we can rewrite this as negative 6x to the negative fifth. And then we want to find the antiderivative. So I'm going to do it both ways. This way and the other way. So first, I'm going to take out the constant, and you're left with x to the negative fifth. Or u is x, n plus 1 is negative 5 plus 1, which is negative 4, over negative 4. Those cancel. You're left with 2 down here and 3 right here. Positive 3 over 2x to the negative fourth. So the other method would be using this, and we're looking for k. They give us, this is our problem, they give us n minus 1. So that means n equals negative 4. Or u equals x. This doesn't apply to this one. No chain rule. So plug it in k n, which is negative 4, u x to the negative 5, no u prime. All that equals our original function, which is negative 6x to the negative 5. Find k. X to the negative fifth cancels. Negatives cancel. You're left with 2 and a 3. So you could say 2k equals 3. Or k equals 3 over 2. Plug that back into this part. 3 over 2 x to the negative fourth. That's the same thing. And if we want to check that, we're going to take the derivative of our answers and use this one to take the derivative. K is 3 over 2. N is negative 4. X, negative 4 minus 1 is negative 5. No chain rule. 2 comes out, negative 6, x to the negative fifth, which is also negative 6 over x to the fifth. And that's our question. So you know we got it right. Good? You got 2 ways to check your answer. So you should be... It's not really hard till the chain rule. Till the chain rule comes in.
It's not hard for you.
No. I would use that if you get stuck, just use the u n plus 1 over n plus 1.
Okay.
And then check your answer.
I think what I'll do is I'll just memorize those
These right
formulas
here?
that he doesn't put on or that aren't
Yeah.
on the quiz right now. I'll just write them on.
Yeah. And that helps me too when I list the and you put in and just plug and chug from there.
Yeah.
Plug and chug. So you got any more questions? No? Let's see what else you got. We'll look at that next week. You want to work one?
Huh?
You want to work one?
Oh. We're almost out of time.
Yeah, we got
aren't
5. Got 5 minutes. Well, yeah, we can end today if you want to. Unless you want to work one.
I think I'm done for the day.
Okay. That will conclude our session for today. For antiderivatives, section 5.1. Thank you. Have a nice day.